Good morning, everybody. This is Carrie Getz with Strategicom with another episode of our podcast. And today we have a real treat. So we're breaking out of literal technology a little bit and we're incorporating some STEM. So we have with us Dr. Heloise Stevance, who is an astrophysicist, which is kind of a different science, but certainly uses coding, certainly ties in with technology. And we're going to chat with her about how she got into this industry and, kind of her journey to get there and some cool things about astrophysiology. So welcome, Doc. How are you?
I'm great. How are you, Carrie?
Great. Thank you. So tell us a bit about yourself and your background and how you got into this field.
Right. So I'm originally French. So if you hear a bit of an accent, that's what's going on here. But I moved to England when I was 18 to study physics and astronomy at the University of Sheffield. And I did my master's there. I even worked for an observatory and then moved on to do a PhD, looking into the three-dimensional shape of supernovae. I finished that earlier last year, actually, in 2019, and now I'm a full-time postdoctoral researcher at the University of Auckland, looking at stellar populations and how they can give us some of the most incredible cosmic explosions like supernovae and kilonovae.
That's really amazing. So that's how many years in school?
About 20 years, 2 decades in school, exactly.
Wow. And since you're at a university, I guess technically
I'm still
in school a bit. Yeah.
A student, that's who I am, yes.
So starting out as a kid, I guess not everybody has this as a frame of reference or something that you might even think about going into. So what sort of kicked you off in this direction?
Well, it was nearly accidental. So I was always a bit of a nerd in school. I was good at most subjects because I actually did my homework. It's not rocket science. And I really didn't know what I wanted to do. I had so many ideas. I was going to be a historian for a little bit. I was going to be a teacher for a while. And then it came to university time, choosing a uni and choosing a subject. And I saw that I could study astronomy. And all of those flashbacks came back from when I was a child and watching all of these documentaries about the Big Bang and black holes and how fascinating I think the universe is, and this eagerness to understand how it works. And I was like, oh my God, I can study that. I can learn about this. This is something I can do. And so I just did it.
It's not something that a lot of women or females really think about, getting into science and math. And part of that certainly is exposure. Part of that is, how you're encouraged growing up by your folks. So tell us a bit about your parents and your home life, and did they encourage you to go into this? Or when you said you were going into this, did they think you'd lost your mind? Or
So, when I was a kid, I was socialized with men a lot, with boys a lot, just because of my personality and how I looked. And I wasn't really aware of all of the biases that are against women. Not that they didn't exist, unconscious bias is a thing that permeates society, but because it's not something that people talked about, I didn't know what I was getting myself into. Even when I chose, that subject, at home, everyone was super, super supportive. My mom was so happy I was going into it. And in fact, when we discussed it, she was like, I'm so happy you're doing that. I started doing a degree in physics when I was your age, but, I was discouraged from continuing because I was struggling with the maths, and I was told that women, are not good at maths and shouldn't be doing that. And she was discouraged out of her degree because of that kind of mindset. It's not something she told me before I picked it, but I think that her willingness to that kind of mentality in society and just do her job anyway, and she's a working woman, she's still working, she's been working in a male-dominated computer science field for 40 years. She's got a loud personality, and I think that has driven my personality and my ability to. I'll do it anyway, even if society doesn't think it's a good idea.
Women as a whole, we really don't give ourselves permission to fail, and failure is to me, I think, should just be eradicated as a word, because if you fail at something, that's just another method of learning. Like, that's not the right way to do things. Let's
Yeah,
try
if
it a
you've
different
learned
way.
something, you've not failed.
Right. And especially when you're doing something like what you're doing, which there's so much that's unknown. We don't understand everything about the universe, or obviously you wouldn't have a job.
I mean, absolutely. I mean, everything is a puzzle. It's hard. Maths is hard. Coding is hard. Like, solving problems is hard, and you have to fail before you're good, before you become good at something. You need to allow yourself that, and society needs to allow you to do that, and not just tell you, well, maybe that's not for you the first time around. It's ridiculous.
Yeah.
No, I think that's definitely an issue.
Yeah. So a lot of your work is around kilonovas and supernovas. And just to geek out a little bit, because this is fun, explain what those are.
All right, so let's start with supernovae very briefly. Both of them are stellar explosions, cosmic fireworks. So supernovae are actually paramount to life on Earth as we know it. Carl Sagan said, "We are made of stardust," and it's completely true. The oxygen in your lungs, the iron in your blood, the calcium in your bones were released by supernovae. Now, there's multiple types. Some supernovae come from compact objects that then compact stars that become too big and then explode, and they release a lot of iron into the universe. Other supernovae come from massive stars that just age and die, and their core collapses, and the outer envelopes explode, and they release oxygen and calcium and all of these gorgeous intermediate mass elements that we need to make planets like the Earth and bodies like we have. But what's really cool with these supernovae is that although they are, especially the ones from massive stars, even though they are so cataclysmic and destructive, they're not the end. Because a supernova from a massive star will, most of the time, leave behind what we call a neutron star. It's a star that's so dense that all of its matter is turned into neutrons. So the protons and the electrons have been forced together to make neutrons, right? Well, if two neutron stars end up merging, if they're in a binary system and they get too close and they merge, then they will create another explosion that we call a kilonova. And this is a very new field in astronomy to study because we can finally observe the gravitational waves that are released in those mergers that we can finally study. And we can also see their lights with the telescopes that we already have. And it's a really new, exciting field of astronomy. And these create some of the rarer elements that we have on Earth, like platinum, gold, palladium, and silver.
Interesting. Yeah, that's kind of out of my frame of reference. To me, just a light year is hard to grasp.
I mean, the scales in astronomy are so massive. Even for us, it's a little crazy to think about. We only think about it in terms of factors of 10. Even ages, we don't think about it in terms of a year. It's like, 10 to the 6, 10 to the 7, 10 to the 8 years. It's factors of 10 because otherwise it doesn't make sense on a human scale. Exactly.
So in your work, obviously, there's some other things involved besides math. So talk to us a little bit about what is your typical day and kind of what is the life of an astrophysicist?
So as far as I'm concerned, I'm a very office-based astronomer. Astronomer and astrophysicist are kind of interchangeable. I don't go observing very often. Most of us now just work with our computers. So I usually start my day by reading what we call the archive, which is a website. It's a repository of new publications that have come out in the field. And you get an email every working day with a list of the new papers that people have published. And you usually scan through the title and the abstracts because there's like 50 to 100 of those to look at. And, kind of pick out what is interesting in your field, what is interesting for you and what you might want to read further. And then it really depends on what I'm doing. If I'm trying to solve a problem, if I'm in the middle of data analysis, I'll be coding a lot, either using tools that already exist. I use a lot of Python, or making my own. Sometimes the software is not available. Sometimes the data formats we use are too weird, or the data formats we create are too weird if we make simulations, and we have to make our own tools. And if I've already got results and analysis that I'm happy about, then I have to communicate those results to the world and to my community. And then I'll be writing and reading what other people have done to compare it to my own results and see what questions we can answer together, to compile all of that in, a publication for a journal.
So that brings up a really good point in that obviously you're doing some coding with Python, which it's a relatively easy language to learn, I think, although
it really is.
Probably what you do with it is a little beyond what most of the rest of us would do with it, but
I don't know.
but there are a lot of different things that come into play where science and technology really marry together in the day-to-day world to make that happen. And you have to be good at more than just one thing.
Oh yeah, absolutely. It's one of the bane of being an astrophysicist. You're not part of a big corporation where you have different teams to do very different specialized aspects of the job that they are experts in. You have to do a bit of everything. We have to be able to code. We have to do statistics, which we're not really taught properly at university. It's something we learn throughout our research life. We have to be able to read and write properly, it's a mishmash of skills, both technical skills and professional skills that you have to just keep developing to help you get to the answer that you want and solve that puzzle.
Yeah, and technical writing is a very specialized thing. And I would say, too, having worked in global jobs, that technical translations are definitely very, very different than just translating regular conversational language.
Absolutely, yeah.
So what's the coolest thing that you've seen occur since you started in this career?
I think the coolest thing I've seen the field do is our first kilonova. So I was telling you earlier that it's a bit of a new field. It's not that we didn't know they were a thing, it's that we are finally able to observe them and observe them in many different ways. Now we can see their gravitational waves. We can also observe the light of their explosions with our telescopes across all wavelengths, from X-ray all the way to radio. And it gives us so much information. It's a fascinating new area that we call multi-messenger astronomy, because you get all of these data. And we're really hoping we'll get more of these objects detections soon, so we can do more science and start building a sample and do some stats on it.
That's right. So explain to just the average layperson like me. Obviously, there's telescopes involved, right? So
Yeah.
Do you fix on one spot in space and then just observe that spot for a while? Or are there multiple telescopes that are fixed on the same spot so you get different perspectives? How exactly does that all come together? And then at what point does observation stop and theory begin?
Do you mean specifically when talking about kilonovae and supernovae?
Sure. Well, yeah, that works.
So,
I mean, there's lots of different concepts. So, to be fair, I checked out your website, and there's a lot of terms that I've never heard. And by the way, her website is amazing, and I'll put a link to that under the podcast. She's got some really great graphics that explain some of this stuff. And to be honest, I've never been exposed to any of this, so it's all kind of very new and very cool to me. Mm-hmm. So yeah, take a kilonova.
Okay, let's take the kilonova that we observed. It was actually really interesting the way that they found the thing, because it's very difficult to find anything with just a gravitational wave detection. It just so happens that with the number of detectors we have at the moment, the triangulation, the localization isn't very good. Now, we got lucky because one of the detectors, the object was in its blind spot, and that helped the triangulation better than if the detector had actually seen it, right? So that's the gravitational wave stuff. And we also had a gamma ray detection that was very close in time. The timestamp was 1.74 seconds after the gravitational wave detection. So we're like, we know this is the same source that's causing this. And so you can then use the localization of your gravitational wave and compare that to the localization of your gamma ray telescope, and whatever is, crossing both areas, is your best search area. This is where you should search for a new star. It's not a star, obviously, it's a stellar explosion, but a new source of light. You should point your telescopes over there and search for a new source of light. And that's what people did. All the telescopes that were available at the time on Earth just pointed at all the galaxies that we knew could host something like that and looked for it, and they found it within, I don't know if it was a few hours or a few days, but they found it extremely quickly because of that triangulation work that they did through this multi-messenger analysis.
That's awesome. And then, so they obviously, once they find it, they publish pictures and papers, or how do they?
Yeah. So
do you guys have a red phone that goes off? Yeah, we found something great.
So this was so insanely lucky and good. The object, it was very close, very nearby, so easy to follow. It was the first time that we observed something like this. So it was actually very kind of secret. So I've got my partner actually is also an astronomer, and he was at the Very Large Telescope at the time observing for his own stuff. Well, the people at the VLT took 2 hours at the beginning of the night from everyone. They were like, no, you can't observe. We are using the telescope. It's something they can do in very exceptional times like that, when, something historical happens. And no, we are using the telescope now for this very exceptional data. But they were kicked out of the observation room so that they couldn't look at it. Everyone knew it was for the kilonova alert, because we knew there'd been an alert. Everyone knew it was for that, but they couldn't look at the data because it was secret until all of the teams that, had that proprietary data had finished dealing with it and done the press release and released the papers and everything. So it was pretty exceptional. I
would think that's really exciting, just to see history being made and something's discovered that's never been discovered before.
Yeah, it was really exciting. A collaborator of mine, he's an older gentleman. He's on Twitter, but I don't think he fully understood the measure when he did. He actually told everyone on Twitter that they'd found this thing. It was a secret thing.
Uh-oh.
And people on Twitter, it was like, oh my God, blow your socks off. We have an optical counterpart of it. And I'm like, surely surely someone official should have made that announcement on a main channel or in the newspaper, not you on Twitter. But it's really funny. It's not that big a deal. People are not that mad. But it is on Wikipedia. It's a fun fact about that kilonova.
That's interesting. Yeah, I just even thinking about this whole topic and this subject and what sort of drives you and spurs you into that realm and into the world of science as a whole, being able to discover something new, I would think is just amazing.
Yeah, it really is something quite lucky to be a part of. It's quite exceptional. It doesn't happen every day, obviously. The tedium of research is real, like in most jobs. You can love your job and still have admin to do. But it is fantastic to be a part of that.
So you talked a little bit about what your average day is, but I assume that, there's not just thousands of astrophysicists around the world. I'm assuming there's a good bit of travel and you get to go meet with some of these other folks and discuss what's going on. How do you get together as a community outside of what you read and what you do?
So conferences are definitely a thing. The field is quite large and everyone is very specialized. It's very interesting how it's very vast, but also very deep. Everyone's got their own niche. So usually we have conferences about very specific topics, and there'll be 100 or 200 participants getting together, and there'll be lectures during the day and, a cocktail in the afternoon or a coffee break. And And it's an opportunity to learn what people are doing and show your science and your results and find, potential collaborators. And it's really fun. We also visit each other at different universities if we have the budget to do so. Depends on your research grant. We get guest speakers come to universities if they're visiting the country. They'll come and give a lecture about. It's not really a lecture; it's more like we call it a seminar because you're not teaching students; you're showing off the science. But we've got that as well. And otherwise, we just use email and Slack.
That's where the technology comes in, obviously. So it's everywhere, and it's great when it works.
Yes. Still don't know how to make the printer work though. That's a mystical thing.
It's magic. So what would you say is kind of the hardest thing or the biggest adjustment that you made moving from being a student into an actual career?
Well, it was a natural progression, at least for me, because you go from being a student, in your early years of university, and you're just doing exercises, and then later on in university, you're doing more researchy kind of topics, and then you do a master's, and that is basically research, and then the PhD is research, and you're building an expertise. You don't know what you're doing, but then by the end of your PhD, you get used to not knowing what you're doing, and then you're comfortable with that. And then you start a job, and it's the same thing all over again. I have to relearn a whole load of things because I've changed topic, I've changed field slightly, so I'm a noob again. But I think you just get used to that, at least in science. If you change field a little bit, or you're working on a new project, you will feel like a noob again, and you're just okay with it. Just learn.
So what was the change that you made from? Is it a change in you're studying a different phenomenon, or?
It's a slightly different topic. So instead of studying the 3-dimensional shape of supernovae, now I study stellar populations, simulations of stellar populations, and I compare it to observations that we have made with telescopes. So it might seem like basically the same thing to someone who's outside the field, but like I say, we can go really deep and really niche into our very specific areas and our specific techniques. And so it is a different field, although it is related, and there is crossover with the general knowledge of that science. It's a different technique with a different set of knowledge that I've got to acquire. And it's great.
So, that's a lot of reason that people get into any of the STEM type fields is sort of the puzzle solving and the fact that it does change all the time and there's always something new to learn and you're not stagnant in what you know. And some people are very comfortable doing the same thing day in and day out. And I have yet to meet anybody in a STEM field that's that way.
No, absolutely. And it's kind of an eternal dilemma. It's like, on the one hand, if I did the same thing every day, I get really bored. But on the other hand, having to learn things every day makes me feel like I know nothing. So it's like, I'm not an idiot. It's just hard. You just have to learn new things. It's okay. Don't panic. It's fine. It's just so exciting that's why I keep getting back to it. And I don't see myself doing a job that's not like that, really.
Have you worked on any projects where they've debunked something that was prior knowledge or prior theory?
No, but recently we have a recent paper. It was led by my boss, J.J. Eldridge. So there was a recent really big press release and a paper in the journal Nature, which is one of the most prestigious historically papers, science magazines. About a 70 solar mass black hole that people had found, and that supposedly the observations couldn't be explained by anything else in nature. Well, that wasn't really the case. And my boss's simulations showed that actually this thing was not 70 solar masses. It was not crazy like that. It was 10 times less massive, so something that's a lot more reasonable, given our understanding of how stellar evolution works. And some other colleagues that she got to work on that as well, demonstrated that some of the analysis by the original team in the Nature paper, ignored some things that should have been common knowledge about one of the telescopes that is called Gaia. And so, yeah, there was a lot of debunking what the original analysis had done, and the original analysis ended up with a result that was really exciting, and the debunked version was a lot more, balanced and agreeable with stellar evolution theory as we know it.
So we're getting close to time here. If you had to pass on some words of wisdom for young folks that are considering a STEM career, astrophysicists are not something you see on career day at school usually. But if you wanted to say something just for STEM in general and your field specifically, what advice would you pay it forward and pass on?
So I think I would say learn to code and learn early. Python is a great language to begin with. There's so many tutorials. The syntax is relatively intuitive, but it will give you an understanding of how computers work and how scripting languages work that is invaluable. So do that as soon as possible. I wish I'd learned to code when I was a teenager, and I didn't. Yeah, no, children didn't do that in school. And if your school doesn't do it, you should do it yourself. You really should. And don't be afraid of failing, especially with things like maths and coding, because you're not an idiot. It's just hard. And you have to suck at something before you become good at something. If you're failing, you're learning. So just keep at it, keep going, and just don't stop.
I think that's a really good point in that we absolutely have to give ourselves permission to fail because that is part of the learning process. But you brought up a good point about your mom, and you had a story earlier that your mother was discouraged from going into physics because she wasn't really great at math. And it was just, oh, you're a woman. You should do something different.
Yeah. And honestly, who knows whether she was really that bad at maths? Maybe she just misunderstood something. Maybe this particular aspect of differential equation she wasn't very comfortable with. There's always a bit of maths that you like less than the rest. But if you're told, well, it's just because you can't do it, you will start to believe it, So don't let other people tell you that, and don't tell yourself that, because eventually you'll start believing it, and it's just not fair on you.
And young people have such a huge advantage today over when you were in school, certainly when I was in school, because I'm a whole lot older than you, but have the internet, which is an amazing resource. And there's always lots of places that you can go for help. And not everybody learns the same from different people, right? Some educators are really, really good at explaining things different ways and making sure that students stay engaged. Some educators are very comfortable teaching a certain way, but if a student doesn't really grasp it that way, then it really is on you as the student to go look at other resources and figure out other ways to do it and try to improve that skill if you want that skill or it's going to be needed in your future career. You shouldn't take the easy way out.
Yeah, and also just learning how to learn and learning how to look for, the resources that you need in itself is a skill. And it's a skill we didn't practice when I was in school, because although the internet was a thing, everything was given out to you and you didn't really have to look for anything. It's something I practice every day, because there's loads of things I don't know and there's loads of things I have to look up and learn how to do and teach myself. And if you can start practicing that from a young age, you'll get used to it and you'll get good at it before a lot of other people. And it's really going to give you an edge and an advantage.
Yeah, I had a boss one time that said, it doesn't matter what you don't know. It matters that you know where to find what you don't know.
Exactly. Absolutely.
Which says a lot, and when I was interviewing people for positions, I would give them some crazy, if this happens, what do you do? And if they stammered for 20 minutes trying to solve the problem and never once said, I would call tech support, I would pick up a phone, or I would go look at the different user groups or online communities or whatever was available then for solutions, then I didn't want to hire them, because in consulting, people don't pay you to learn on the job. They pay you because you know how to find the answers to things.
Exactly.
Yeah. So, and I would assume that your group as far as science goes, is probably relatively tight knit, since there's not just millions of you.
Yeah, especially in our fields, it's You tend to know people.
So
Yes.
is it competitive, or is it very much everybody helping each other out, or a bit of both?
A bit of both. It's of course it's very competitive, but it's not like most people are not cutthroat. Um, it's very competitive because there's fewer positions than people who apply for them.
Right?
So, but it's more of a you're not gonna have people do bad things to you. You just feel a lot of pressure to do well and to work a lot to try and just stand out in the crowd. What we do have is, because this job is for a lot of people also like their hobby, it's a big part of their life and their identity. You can get quite a lot of emotional responses if people have a theory that they really like or that they have developed or something they really believe in, and someone comes along with a different idea, and you can have a certain clash of personalities. We've got quite a few cases like that in astronomy.
Yeah, I don't think you guys have the exclusive on difficult personalities.
No, I'm sure we don't, and it's very interesting because with all of these gender roles of women are emotional and men are logical, it's always the men, which is like, oh my god, it's always them who have like clearly no understanding that they're having an unreasonable reaction to something or to someone's idea, and you just want to ask them to just go to therapy, sit down and have a conversation with a buddy. I don't know, sort yourself out. It's seriously, it can get quite nasty. Like we've got problems with bullying. Like all areas of science and technology have that, and I'm sure of life as well. But we've got issues with bullying, and a lot of conferences now have code of conduct because we've had people. I've got friends who've seen senior people in the community like threatened by something that a student says on the stage, giving a talk, and them having a go at them, like shouting at them and telling them that their ideas are stupid and their science is stupid, like in front of everyone. It's like, you are supposed to be a dignified member of your community, and this is the way you behave. Like I don't know. We've got a few cases like that, but most people are delightful and fortunately don't take themselves too seriously, because at the end of the day, we're not curing cancer, right? It's a fantastic science to be studying and to be doing, and it's fascinating to a lot of people. But we have to work together to get to the answers. It's the only way to do it, and most people are team players, and I'm very grateful for that.
That's a good thing. Every industry has their few. People sort them out pretty quick and know who they are.
We know, and when we and it's really funny because that one in the audience and the other one's giving a talk on stage, and you're like, the Q&A is going to be amazing,
right? Or as soon as they put their hand up, everybody rolls their eyes. Oh, here it goes.
Like, oh, I know this is going to be good.
Absolutely. Well, Heloise, I want to thank you so much for your time this morning. It has been just wonderful learning new things and getting your perspective from science and really kind of how it ties into technology and being a woman in the field. I'm going to post a link to your website. I encourage everybody to check it out just because, well, if you have a little bit of an inner nerd, you'll really find it very entertaining. I want to
thank you so much for having me, Carrie.
Yeah, absolutely.
Thank you so much.
And safe travels on your next go.
Thanks so much.